Class, we already have the value of our principal. Okay, how about if R is the variable without a value, or R is the variable with the missing value? Okay, so again, we use the same values for the other variables. So to solve for R, okay, we have the solution. We have 3 lines here. So in the first line, we use the same formula, and then we substitute the other variables with their given numbers, except R. Okay, so we maintain this number in the left hand side. Okay, this number, we maintain this one. We wish to evaluate these terms inside the parentheses, but we cannot readily combine them because this is a number, a pure number. This one is, this term contains a variable. So we maintain these expressions inside the parentheses. Okay. In the exponential side, we have the product of 4 and 2. So we have the exponent 8. So in the third line, okay, so nothing happens to the left hand side because 106,059 and 8,848 thousands is maintained. 100,000 is maintained. These expressions here are maintained, and we have 8 as the exponent. Since we are really interested to solve R, we have to cancel 100,000 by division. So we divide the right hand side by division. So our divisor here is 100,000. So what you do in the right hand side will be done in the left hand side. So our divisor for the left hand side is also 100,000. Because of this process, okay, so 100,000 will be cancelled. To evaluate these numbers in the left hand side, we can have the scientific calculator for faster computation. I will show you the process and the next set of lines of the solution. Class, we have this another set of solution lines. The first line, you can see that we have this expression in the right hand side, a binomial raised to the power of 8. In the left hand side, we have the division of two numbers in the second line of solution. In the right hand side, okay, nothing happens. But because we are really interested to solve the value of our R, we need to cancel the exponent 8. We can do so by applying the 8th root of each quantity. Okay, so our target really here is to cancel 8 by getting the 8th root. So because we are getting the 8th root of the expression or quantity in the right hand side, we also get the 8th root of the quantity in the left hand side. Take note that if we say 8th root, this is equivalent to raising a certain quantity or expression to the power of 1/8. Okay, so 8th root is the same with 1/8 as the exponent. Okay, so we can rewrite 8th root as these expressions, where you can see that each expression is raised to the power of 1/8 because of 8th root. Okay. So in the right hand side, because of raising this expression to the power of 1/8, this is cancelled. Because 8 times 1/8 is 8 divided by 8, and that is equal to 1. So that's why 8 will be cancelled already, because it is multiplied by 1/8. How about this one? This lengthy single number raised to the power of 1/8. So we need the help of our scientific calculator for this. Class, I'm going to use the scientific calculator to compute the raising of the single number 1 and 61,598,848 billions to the power of 1/8. So we encode first the number, but make it sure that we press first the open parenthesis, and then we encode the number 1 and 61,598,848 billions. And then we have to press this inverted letter V, and then we press another open parenthesis. 1/8 is actually equal to 1 divided by 8. So we can encode here 1 divided by 8 to represent the 1/8 as the fractional exponent. And then, we press the close parenthesis, and then we press the keypad with equal sign. So that's it. We have the value 1 and 75/10,000ths. Okay, class, this is by using our scientific calculator, we obtained this single number. And because of raising the expression in the right hand side to the power of 1/8, so we only have the binomial in the right hand side. So the power of this binomial is already 1. So because the exponent is already 1, we can write this binomial simply as simple as like this, without the parenthesis anymore. Okay. So next line, we have this. Okay. So since we are really interested to find the value of our R, we we remove 1. So we can do so by subtraction. Okay. So we subtract this. We subtract the left hand side by 1. Okay, sorry for that. Then we also subtract this one by 1. Okay, class, since we are really interested to get the value of our R, we can remove 1. Okay, we can do so by subtracting that by 1. Okay, minus 1. So we also subtract the left hand side by 1. So we also have minus 1 or minus 1 here. Okay, so because of this process, in the right hand side you only have the single term R divided by 4, and in the left hand side we have this minus 1. Take note that 1 is also equivalent to 1.00. This is actually followed by many zeros. Like that. Okay. So 1 minus 1, 0. And this decimal part here, minus the zeros in the decimal part also, we have the difference 75/10,000ths in the left hand side. So as you can see, we have single terms each side of the equation. So this another process that we have to perform to really get the value of R. So since we are again focusing on the value of our R, okay, next process we have to remove 4. So how can we remove 4? It is done by multiplying this term by 4. Okay. And because we multiply 4 in the right hand side, we also multiply 4 in the left hand side. So because of this, we can cancel 4, leaving only R in the right hand side. And if we multiply 4 by 75 10,000ths, the result, the product is 300ths. And this is actually the value of our R, the rate. So we can interchange this equation. We can also say the rate or the variable R is equal to 300ths or 0.03. And if you want to convert this to a percent form, you can move the decimal point 2 places to the left. Okay, as you have done moving the decimal point 2 places, then you can write the decimal point mentally as the percent symbol. So we have this answer. Okay, this is the value of our R, 3%. Okay, so in my next vlog, I will discuss how to compute the missing values of our N and the variable T. I hope you enjoyed my discussion today. So class, this is Summer TV and goodbye!